All right, let's start again. So my name is Shelley Lambert. I'm from Ottawa, Canada. I'll likely fall off the edge of this stage because I get really excited when I talk about testing Java. On the credits there, it says I'm an AdoptOpenJDK committer. I'm also on the technical steering committee of that open source project, and I'm going to tell you about that project. I'm an Eclipse OpenJ9 committer. I'll also mention this project. And I'm the IBM Runtime Technologies test lead. It's a long title. What it really means is we test programming languages, the ones that we deliver, the ones that we actually have as products. So that includes Java, it includes Node.js, and it includes Swift at the moment. We have a project called Eclipse OMR, which is the low-level components of a programming language. So that's below the layer of a programming language at all. So we're testing there as well. But today is actually talking about Java. So I'm going to set the stage. How many people in this room use Java or test Java applications? Oh, so quite a few. How many people in this room have made swear words because Java crashed underneath them? Okay, so it would have been maybe partly my fault. What we're trying to do at the moment is take this established language and test it in the open. And I'm going to tell you a little bit about the history of testing this language and why this is a new story. So first of all, in the Java ecosystem, it's a great period of change right now. We have a lot of different things happening in the Java world at this moment. For example, there's a large installed base that is no longer free. It used to be you could pick up a JDK, an SDK from Oracle, and run it and use it. And as of February of this year, they're beginning to charge you for it. So at AdoptOpenJDK, what we do is we build Java and make it freely available for people to download. And we're testing it at a very high professional level of testing before we deliver this to commercial, to corporations, to individuals. So that's one change. We've seen a mass migration of people coming to the project and downloading the binaries to use in their companies and on their desktops. Also in Java, it used to be this programming language moved quite slowly. We would release maybe once every few years a large major release. So Java 5, Java 6, Java 7, the cadence was every few years. Now we're hitting a different rapid release cadence, so we're releasing versions multiple times a year. There are two long-term releases of Java, Java 8 and Java 11. Those will be around for a long time. 2025, looking far ahead, they'll be in support for a long time. But in between that, we have very rapid releases. Java 9, Java 10 are already out of date. We're now working on Java 12, Java 13, and this is happening very quickly. So it means that we actually had to change how we're testing and how we're releasing this software. Many of you who know Java as well know that after Java 8, there were major language features that were added, so modularity. And this actually has had a tremendous change in some of the testing that we do as well. And finally, the world knows this. It used to be back in the days of early Java, we cared about our customers that were big banks running on giant mainframe computers, and that was the workload that we cared about. But now with the cloud deployment model, we care about a smaller footprint Java, we care about fast startup, we care about a lot of different things. So our deployment models and workloads have changed drastically. Quickly, I'm not going to go into too much detail. What is Java? It's this development kit. It includes the runtime environment and a bunch of tools, all of which we want to test. What is OpenJDK? This is the reference implementation of Java. So this is a source code repo where you can go and pick up the source and build your own Java. And in fact, many companies do this, where they take it, fork it, customize it for their own purposes. So Twitter, Alibaba, companies like this. And there are many, many commercial and community builds. So some of those I'm going to mention, obviously the Oracle commercial version. IBM, we have a commercial version as well, but we have also open sourced our version as of within the last couple of years. So I'm talking about testing that, but I will reference the fact that we also test internally within the company. SAP as well, Azure, Amazon all have their own distributions of Java. And at AdoptOpenJDK right now, we have two major implementations, two major versions that we're building and testing. So OpenJDK, that source code repo with the hotspot virtual machine underneath it, and OpenJDK with the Eclipse OpenJ9 virtual machine underneath it. And that one is near and dear to my heart, obviously, because I'm a committer at that project as well, and I help test that within the project. It's particularly good. It has a history of coming out of the micro edition world, so it's particularly good if you want a very small footprint, a very fast, efficient Java that runs in a containerized environment and is optimized for that environment. Okay, but we talked about, there's a few people in the room that use Java. If you look in GitHub, it's the second most prevalent language there behind JavaScript. We have thousands of customers, and we have millions of users. And I took this screenshot, I guess yesterday, at AdoptOpenJDK. That's how many downloads we have as of yesterday. And that was as of today. So what we're seeing is a very quick migration to us, and it's accelerating. So within the last month, we've seen a few extra million downloads, and it seems to be getting faster and faster. So I care about whether these binaries that people are downloading and using are of a high quality. That's my job, to care about that. So what are the challenges here? Obviously, we have the fact that testing of Java, you heard there's a lot of different implementations in the world. It's private. It's done privately for the most part. It's fragmented. It's done behind closed doors, so you can't see what's happening. And in this case, I feel it's a very inefficient use of our resources. Everyone who is in a test team probably feels that. No one ever really wants to invest in testing. In fact, the team sizes are shrinking. There's not a whole lot of resources committed to it. So the fact that we're wasting and being inefficient about how we test this language is bothersome. So we at AdoptOpenJDK have reached out to every implementer to ask them to come together and share their best tests, their best practices, and actually join forces in a common goal. So we have a large number of active versions as well. These are all challenges for us, and underneath all these tests that different people are using, there's a lot of different frameworks to deal with. Okay. I also want to just talk briefly about testing scope from my own personal life. This is kind of a scrappy picture, but what it's really showing is that I and my team a core team of 5, test the IBM JDK, which is the commercial product, but we also test this OpenJDK with OpenJ9, and you see that mention of OMR, and I had mentioned earlier that is a language agnostic components for any runtime, so you can set any programming language on that. That includes things like a port library, a thread library, a garbage collector, a compiler. So we actually have a lot of very innovative ways of testing that piece. I'm not going to have time to talk about that today, but things like injecting bytecodes, injecting intermediate language at that layer so that we can get around the fact that then if you plunk 3 or 4 different languages on top of that, then I would have to test the same thing 4 times. If I can shove tests down as low in the stack as possible, I can test less. I can get away with testing less. But what today we're talking about mostly is the work at AdoptOpenJDK, so those bottom 2 pieces, the OpenJDK with OpenJ9 and OpenJDK with Hotspot. So AdoptOpenJDK Quality Assurance, or I'll call it Aqua, because it's easier to say. Really, the mission is to make quality certain to happen, which is really the meaning of quality assurance, right? So, as I mentioned today, the world of open testing in the Java ecosystem, really there's a set of open tests at the OpenJDK project, around 6,600 tests. There's a compliance suite that is not openly available. You need to have a license, you need to be given a license, and they have the right to not give it to you. So this is problematic, obviously, if we want open and transparent testing. And then, as I mentioned, the builder-specific testing, stuff that's happening inside the walls of these companies that are making their own implementations. We don't know, it's unknown. What we want to do at AdoptOpenJDK, and what we are doing, is there's the roadmap. We want to have a set of tests that cover security, functional correctness, performance, scalability, essentially the whole, every aspect of making this quality certain to happen. A little picture of really the variations of what we have to test. And I've mentioned now that Java 9 and 10 are already parked, they're already defunct, so we can take those out of the mix now, but we're working on 12 and 13, and very quickly it will come to the next version. We have the 2 main implementations, but we also build some of the other implementers' stuff, and we also test it. The reference implementation actually comes from Red Hat. We don't build it, they build it, but we get a signed version of those binaries and we test it. It's very helpful when it comes to knowing and being able to triage tests that we have all of these different varieties, because we can say, oh, it failed against 4 out of 5, what's going on? And it is very useful. I'll talk about that a bit later. We have a lot more than just these platforms that we test on, because Java is the write once, run anywhere language, and it's free and easy to Java developers because the people who implement the language take the pain away by writing these platform-specific pieces, which we want to test. So we've broken out the testing into various groups, and they're mentioned there: OpenJDK, functional, performance, system, and external, which I'll talk about in a minute. If you look at the fine print of those numbers and you calculate out the fact that we may use a test and use various inputs for that test, in fact, for a system, which includes load and stress testing, we might run tests multiple times, 36 different types of modes that we run it in. It quickly ramps up to a very great number of tests run nightly across several servers, obviously, and several build farms, but that just gives you a sense of the size of it. What we're really doing at the project is we're curators. Like in a gallery, I'm picking the finest of tests and hanging them on the wall. No, we're actually running them, and we're pulling them out of open repos. It's very important to us that we're taking open test material. It's very important to us that people get to see what's happening. So a little bit more detail about gathering these great tests. The functional test suite, much of it comes from the OpenJ9 project. It's around 20,000 tests. We also have an aspect of the functional test directly in the Adopt project, and those are the multi-byte character set tests. So for languages that are written in Cyrillic or a lot of the languages that require Unicode, there's a lot of tests in that suite there as well. The OpenJDK tests, as I mentioned, were already open. We pull them from that repo and run them at our project. There are around 6,600 tests that get run. System tests, this is a bit of a lie. It says 25,000 tests, but those are also run in special ways. So we take those individual unique tests, and some of them are load tests. So they get run in thousands of threads, hundreds of thousands of times to see if we can bring the runtime to its knees. And then the external test. This is actually quite important to customers, to people who want to use Java. Does the application I have run properly with the thing you built, with the binary that I'm going to download? So we've picked a selection of Java applications, large ones, things dealing with big data, things dealing with common functions that really we want to make sure are working properly, and we run their functional suites. So we have Elasticsearch, we have Derby, we have Jenkins, we have a lot of different applications there, and you'll be able to see that when you go to the repo. It also includes the micro-profile TCKs. So there are 4 variants of those as well, depending on what you care about. And then finally, performance benchmarks. We're just starting to put those online at the project, but the plan is to continue to select things that, 1, are useful for developers, but 2, give people who want to download these binaries a view to the health of these and how they compare, in fact. Okay, but I talked about one of the challenges here. One of the challenges is actually that each one of these types of tests may have several test frameworks underneath them. So we have a command line that I could tell developers who we are also serving with this piece of this code base of tests. I could say, you need to learn all of these different frameworks and you need to figure it out and you're on your own, good luck. And they would tell me something very rude probably back. They don't want to necessarily they don't have the time to learn all of this stuff. We need to make it easier for them. So instead of having them learn that, we've actually laid a thin veneer, a thin piece of something in the way to make it really easy to deal with all these different frameworks. In fact, now I can run that entire suite by running make functional. I can do the same thing across the board, even though underneath it's quite different to someone who's running these tests, to a developer, or to an automation system. It's a lot easier to deal with now. What else have we made common here? It's not just the running of them, it's the disabling them, the re-enabling of them. In a lot of ways, it's looking at the test results, which also are not in a common format. We have enforced a standard that they really must follow. Not really follow, we actually just generate a common output so that they're useful for our automation. The other notion is that we're an open source project. We don't always have all of the machine resources. So when I showed all of those platforms and that maybe we're running 50 million tests a night, how many machines does that take? How long does it take to run all of these things? For the daily test runs, not counting performance benchmarks, it's around 31 hours of testing daily, which means you need a few machines to cover that. So daily, in fact, we don't run the entire set. Daily, we run a set that we've tagged as sanity, deemed as more important tests, deemed as tests that find defects quicker or more often. Extended is run weekly and against the release builds. And special may be run on its own custom schedule. Special sometimes requires special hardware as well, so we've separated that group of tests out in its own level. So we break them out into the 3 levels, and we go, sanity is the thing that runs most often. It's the thing that if you were doing pull request testing as a developer, that's typically what's triggered. Extended is obviously extra testing that maybe is important, but really we just don't have the resources. If we had those resources, we would likely run them more often, but realistically, we'll never have enough machines. So that's how that works, a graduated type of testing that we apply. And again, just to remind, what are we really trying to accomplish here? For the enterprise customers and consumers of the binaries, we want to make sure the thing is functional. We want to make sure it's secure. Performance, it has to pass certain performance bar that is set, and also scalable, so that can it cover the workload that the enterprise customer has. So enterprise customers care about those things, but so do developers. So we never forget about the developer that needs this test material as well. So at the project, the Aqua manifesto, if you will, the criteria by which we run this and we deliver testing, it's quite simple, really. There's really just, 5 major points that we try to follow. We want the test material to be open. We want to run it in the open. We want it to be transparent. It needs to be a diverse set of tests to cover those functions, that set of requirements that I mentioned that customers want. We want the test material, we need it to evolve alongside the implementation. So this isn't a case of, we gathered this material and now we've put it there and that's where it'll stay and we're never changing it. Obviously, that's not going to work when new features are coming every version of Java. New test material needs to be incorporated, so we need this story to be adaptable, flexible, easy to add, easy to evolve. And I'll talk a bit about each one of these points now. Also, portable, what does that mean? We made it our mission to make it easy to take these tests and run them on a developer laptop. Very easy to set up, very easy to run, but also to make it easy to run the automation in any one of the companies. Any company that has an implementation of Java can pull our scripts and our Jenkins files and run them in their own labs on their own build farms. And then finally, the tag and publish piece. So when we release binaries and someone goes and downloads it, we want some accountability here. We want them to be able to click, go to the test results, be able to get the exact test material that was used for that binary and rerun it if they wanted to compare how they did with how we did and make sure that it's actually the same story. So why do we want? I'm going to go through those bullet points now. Why do we want open and transparent? Well, open languages deserve open tests, and it's quite surprising that we haven't had so many open tests in this ecosystem, but we're hoping that we get all of the implementers involved and we bring that to the open, because really, if someone says, yes, I tested it, trust me. It's maybe not the right approach. If you want a dynamic open language, you want people to be able to run testing easily. This really strengthens confidence in the language, in the binaries that people download. But I think I'm going to skip right down to one of the most important points of this. It actually drives innovation. And why? Why do I think it does this? I actually think it does this because developers are able now to play more easily. They don't have to submit a change to some project and wait to hear back, did it pass some unknown tests and did it do the thing that it needed to do. They can liberally try new features, liberally try out things, test it locally. It speeds up development, and it helps invigorate the creative process, I will say. And more importantly, it also helps build community. Oh, the diverse and robust tests. Why is this important? Well, that's important to fulfill those enterprise and developer requirements that I mentioned before. And I think we already talked about the different groups or categories of testing that we're making sure is part of the Aqua story. Obviously, we need to cover those different Java versions, the different platforms that Java runs on, different implementations, so that's the different virtual machines underneath. There's a lot of stuff happening now with people trying different types of GC and compiler technology, a lot of different VM underneath. And then obviously the different applications. So we have a desire to reach out to anyone who, if you have compelling test material, I want to talk to you after. I would like to talk to you about contributing them to an open project so that it can benefit the entire community. Again, I'm just revisiting the point that we talked about earlier, the different levels. The main category of tests we have, this is one of them. An OpenJDK is a category or a group. If I wanted to run these, I'm setting this up because I'm about to show a little demo of how I would run this locally. But I can also say make sanity OpenJDK, and that's going to let me run just the subset that are tagged as nightly or sanity. I might just want to take a single target that forms the sanity set. So in this particular one, I happen to know it's only 8 targets in that set, but in other sets like the extended, there may be a few hundred targets. And within this target, the JDK math target, there are only 40 tests, but in some targets, there may be thousands of tests. Depends on the actual group. But this just gives you a sense of how we can have it be that I might be a developer who doesn't want to run the entire OpenJDK suite because that's 5 hours of testing. But I might want to run maybe the JDK math, which shows a few minutes. It's one of the smallest groups, so it doesn't take very long. But what if I'm just trying to fix a defect, something that was found that caused this particular test to fail, and I just want to rerun it against my build, so there is a way that I can do that. And how does that veneer work? How do we actually allow for all of this grouping and granularity and tagging and slicing and dicing? Well, we do it in a playlist. So we actually just define the targets in the playlist. And within that playlist, we also say, sometimes tests aren't appropriate for certain versions, so we can define that within this playlist. They might not be appropriate for certain implementations, and we can also define that. Before I get moving through the rest of the items, I just actually want to give a quick view of a playlist, an actual playlist, and showing that, yes, in this case, if I look at this target, and we have thousands of targets, but if I look at this particular target, it's kind of interesting. This one is only applicable to an OpenJ9 implementation. So what happens when I actually create or auto-generate the makefiles, if I had told the system that I was about to test a hotspot implementation, this one wouldn't be generated, it would be skipped for that particular purpose. So we do this kind of on-the-fly decision when we're generating these targets. Okay, so what does this actually look like in reality? Just for the purpose of me being able to fast forward through this, This is me last night just setting up. So I'm actually going to go to our main project, this test project, and I'm going to clone this repo, right? Once I've done that, and it takes a little minute, and I believe I fast-forwarded, I'm going to call a script called get, and it's going to go get me a few additional pieces of the puzzle. So once I'm in here, I'm going to call get. What happens here is it actually goes to another project, and it goes and picks up that test kit gen, that thin veneer, and it picks up a few more tests. So the extra 20,000 tests I mentioned also get pulled over at this point. I'm fast forwarding now because I wanted to show at the very beginning here, I have also told this system what test JDK I'm using, where it lives. So then we auto detect what Java version it is, what platform it is, and what implementation it is, so that we can set a bunch of variables when we are about to run the configuration of this. So this is actually, you know, maybe it takes you a few minutes to set up, but what it is actually doing is allowing me to run every one of those 250,000 unique test cases on my laptop, each one. In this case, I'm actually really just saying out of those 5 categories, I only want to compile 3 of them because it takes a long time to compile that many tests. So in this case, I think of those 3, it still takes 10 minutes to just to compile the source code for the test material. Obviously, this is also why I'm not doing this live. I didn't want you to have to sit through 10 minutes of compilation. So first, we've generated the test targets. Now we're going to compile. In the case of some test material, a part of this compile step you'll see is also going and fetching dependencies, and it may even be going and fetching more test material. So for the system tests, we actually go to 3 other repos and pull yet more test material. All right, so that was 10 minutes. You're welcome. The next thing I'm not going to run fully here is the Sanity OpenJDK example. That's around, on my Mac, would take around an hour and a half to run that set of tests, but just to get the sense of that would be what you would do. Most of the time, the use case for developers here is to run an individual test target, like the JDK math example that I talked about earlier. And in this case, you can see that we actually generate a summary there, and you can see that there are test output folders that get generated each time you run a test. They're time-stamped so that you can get at more information within it. You also see that there's a .tap file, and if you go way back in history, you'll know that that's the test anything protocol. And it's the lowest common denominator result output that you can come up with, and that's what we use to force all of these test materials to report to us the very minimal amount of result that they would. It could either be that they passed, failed, or were skipped, and with some additional comment in that. The reason we do that is when we go and run this in Jenkins, we want to be able to have a visual report and have some sort of way of determining across all of those tests what has happened. Yeah, so in this case, now I've run some functional tests, and you can see that it was a single target, but in that particular case, there were 124 tests in that target. Speeding through, I'm taking a look at some of these other tests, and I'm showing an example of running them. In this case, it's a load test, and the main reason I wanted to show this is because it is a single test target, but you'll notice that in this particular case, it launches a bunch of different Java threads. It has a bunch of different test classes that are running, and then it iterates through them a lot of times. So this is one form of load test. It's not particularly heavy load, but these are all tunable, so that if I wanted to up the number of threads that were used or up the number of iterations, that's all completely tunable. So on this particular example, that's 1,900 tests that were run just in that time frame. But what do we do? For the most part, we don't have to deal with this on the command line at the project. That's for developers to be able to get access to this material. What we're actually doing is running this within Jenkins, and in the cases where the test material can output JUnit, we obviously take advantage of that so that we can see more details about the tests. Most of the material we can force or massage it to do that, so we have that ability. We also created grinder jobs so that people can come in and select what platform they want to test, what target they want to run, if they want to pick up the nightly build from the project, or if they want to upload their own build, they can do that. And in fact, the upstream obviously is what gets triggered in our automation. There's a whole lot of parameters here. This is for the power user, if you will. If you were trying to debug something and you wanted additional Java options on the command line or wanted to replace them wholeheartedly, there are ways to do that. There are ways to iterate over this. Why it's called a grinder is, say I wanted to run an individual test class because there was an intermittent failure. Happens once every 100 times. We can do this easily through this tool. So we use this rather heavily, and we use it for a number of reasons. The grinders typically are used for small targets. The bigger targets are run nightly, obviously, and triggered from a successful compilation build. So if the SDK itself succeeds, that nightly build succeeds, it kicks off all of this testing. So let's fast forward a little bit. I want to get to, so this is an example of one of the nightlies. It's not particularly interesting except for the fact that if you go here and we can take a look at the test result, what happens at the project when we get that? We're really a small team. The core team is 5 people doing this, plus the OpenJ9 stuff, plus some internal stuff at IBM as well. We need this to be as easy as possible for our own sake. I will say that I'm actually quite fortunate. I feel quite fortunate that we're a small team because that makes us have to be innovative and have to look for ways to do the impossible. So in this case, what I was taking is this is a new failure, one day old, so I can go and grab this and run it in a grinder and see if I find that problem repeating and see if we can't get a fix for it, have someone create a developer build and rerun it and get that into the system very quickly. All right, so moving a little bit further ahead, the other thing I wanted to mention is I'll actually get out of this for a moment because what I wanted to mention really is that if you want to go get the binary, right, at the project, you can actually just go freely available binaries, fully professionally tested, as you may have now understood. You can get different versions. You can get the release builds, or you can go over into the nightly zone or older releases. If I want to look at the nightly builds, which is the thing I more care about because I'm constantly trying to triage any new failures that come in, you can see that we have both the pure binary in a zip file, or we also have installers for a lot of platforms. So if you're looking for a freely available, pretty awesome Java binary to download and use, this is the place to go. Why why I bring this up at the moment is if I want to go, if I want to go and monitor just that one single Jenkins server at our AdoptOpenJDK project, I could just go to it. But I also have to monitor the server at the other project and, in fact, the server at, internally. So I can actually run this. We created this tool, and it's also open source. It's at the AdoptOpenJDK project, and it's a tool for monitoring Jenkins builds. And it's generic enough that it can monitor any kind of Jenkins build, but we've tuned it here in this example of this instance running to help us step into some of the builds that we have and how they're structured. I don't know if this is going to be live or not, but what this is showing you is of the 831 test targets that were run on this particular build, 35 of them failed. And I can go and kind of dig into that and say, oh, shoot, on these platforms I've got these failures. I have 4 test targets that are failing here, 4 on this other. Maybe I'm going to dig down and look at this. I'm interested in this platform. Someone is asking me about it. So I'm going to look at this single failure that's running out of this one. And I see that that is new. And so that makes it even more interesting for me. If I wanted to look at the console output, I could. But do I really want to do that? No, actually, I want to compare it across platforms. So what we've really done is created some tools that make it easier for us. And in fact, interesting. This tells me a lot because it's telling me where this is failing and where this is not. It's going to help us pinpoint the problem quicker. So this test tool, which we call a test result summary service, we're adding ways of looking at the results and manipulating these results, storing them longer term in a database because, as you know, with Jenkins, you're only really storing a few builds. But what happens if I have an intermittent failure that's failing once every week or something longer, and I haven't kept the history? So we can actually also look at a deep history of a particular thing to say, did this ever happen in the last year? But I won't spend much longer on that. I just wanted to say that exists. That's there for anyone to use. It includes the ability to take and parse different performance benchmarks. And what we've actually seen happen, well, because I'm IBM runtime technologies, which means not just Java, Node.js, and Swift, and other languages can use these tools as well and use them to monitor their performance tests if they're based in Jenkins at the moment. So we have a team from trying to run Python performance testing there, and soon it will be the Node.js team as well. So all of these tools, completely reusable, completely open. If you need something like that, you can go check it out. Okay. Finally, I guess I just wanted to say, at the moment with the system we also have a nice way of dealing with graphically looking at those benchmarks. I think that I had captured it here. We don't have this running on the live external instance yet because we haven't enabled all of our performance benchmarks, but you can likely see that there is a tab up here, and this is an internal instance of this tooling monitoring our internal Jenkins, and so you can see that it's showing me a history of some of the performance benchmarks and letting me interact with it in a useful way. Okay, quickly I'm going to talk about a few other tools that we have that we're going to open source as well. This one is kind of interesting. It's based on some research that actually came from a few Google employees, but the notion that you can cheaply and easily predict where bugs live. And the algorithm, and I'm just going to stop this for a moment, The algorithm that is used is very easy to calculate. It's looking at source code, and it's looking at files that got changed in a repo and saying, this one got changed because of the following issues, and it got changed this many times in this period of time. And what it turns out, the research shows that if some file changes very often with fixes to defects, it is more likely to have defects in it. So why does this matter? Well, for us, this is a piece of information that we can use to guide us to add more testing against certain areas of code. But I'll let you in on a little secret. It's not in this presentation, but it is also a feature that we can use when we're applying deep learning and machine learning to some of the work we're doing. So we have a couple of projects that we haven't pushed to the open yet, but we will be pushing to the open, where we're taking this type of information into our model to be able to test smarter, if you will. All right, so all that's really doing, just to say, is it's letting me analyze certain pieces of information. This is another tool which we call core analytics. So if you've had Java crash on you, you know it creates a core file, a dump file. In that dump file, there's a lot of information, information that could be quite useful for us from a test perspective. So in this case, I'm scanning and looking at that set of data and saying, oh, out of those 300 or so core files that I have, where something crashed horribly, what were the JVM options that were in use? And it can let us know, in fact, what is the combination of inputs that we could use to find more defects. So this is just giving you a little view of that tool and giving you the sense of how this is also information that we can feed into a deep learning model. Okay, so that's a lot of talking, right? So back over here, essentially, I've kind of given you the overview of that test result summary service. That's where an initial work in progress instance is living. It's going to be fleshed out as we move forward on some of that work. But I wanted to quickly get to the other points in our manifesto in the criteria by which we run testing at the AdoptOpenJDK project. That notion of continual investment, I hope you get the sense that we're trying to do the best possible job. We're trying to reach out to everyone who has an interest in this and bring them together. What we really want to do is refine the automation and tools that we have to make it easier for anyone to test. We want to care for these tests. We want to love them. We want to fix them. We want to make them better. On that note, then, the technical steering committee, there's a couple of us that care exclusively about testing, and we are putting together a process where this material and this stuff is reviewed quarterly, so that we have a process in place where we're not just letting this stagnate. It's quite an active, a lot of activity going on at the project right now. And by our July release, which is the next release of Java that we have, we are hoping to get this first version of Aqua live. So there's a lot of work still to be done to meet that deadline. But along with that comes the fact of community awareness, why I'm here today, maybe, making people aware of some of this work that we're doing. Of course, you can't assess the tests, and you can't make decisions about what's the right test suites to use and what's the right thing to have unless you gather metrics. So we also have a lot of people looking at gathering data. We have some code coverage information. But as you all know, code coverage doesn't tell you everything. It might tell you that there are gaps in testing, but it doesn't necessarily tell you that you've functionally covered that source code, because you can have a really crappy test that hits all the lines in a method, but doesn't actually find all the defects in the method. So yes, we want code coverage, but we're not just going to rely on that. We're going to also look at other things that we can gather. I showed you some bug prediction stuff. Of course, there's the notion of mutation testing as well. Luckily, we have access to the whole stack, so we can insert defects into the SDK to check that our tests are actually good in finding the defect we inserted. So there's a lot of techniques here that we can use and a lot of stuff we can gather, and we're in the process of doing that. The comparative analysis piece, I briefly mentioned it, and I didn't show it in that test tools, but what we're trying to do with some of the tools we're creating is make it super easy to compare how the different tests behave across the different variations. So if it's whether it failed in 8 but didn't fail in 11, or it failed in this hotspot implementation but not OpenJ9, that gives us a lot of information about the test material. And in the tools that we're writing, we're making it easy to side-by-side compare to make our lives easy. We want to reduce the time it takes to triage these millions of tests, obviously, because the more time we free up for ourselves, the more we can actually improve the whole system. Okay, so the portable piece, you've seen that I'm able to run all of these tests on my laptop. I also have enabled every implementer of Java to run them in their Jenkins farm. We have a README and a doc that explains how you can go and pick this up. It's quite easy to do. And we're also making it easy to add new platforms, which is a constant thing at the project. So AdoptOpenJDK, what are the differences between OpenJDK and Adopt is that if a customer wants Java on a particular platform that is not officially supported anywhere else, we'll try to help you out. So we actually test and have build and test Java on a lot of platforms that no one else does. And then finally, the tag and publish. We're getting to the end here. Finally, the tag and publish on releases. So the audit trail, this is really just so that you can trust what we're doing and you can see what we're doing, and it's not this case of what's the magic behind the curtain. They said they tested it. I have no proof of it. You have proof here, and in fact, you'll be able to download the artifacts with the binary so that you can see what testing was run against it and how it performed. So revisiting that list again, really, I don't need to go through this again with you. I think I've impressed upon you, these are the things that guide us at the project, and these are the things that make us feel we have tested this set of binaries for business use, for enterprise business use. So our goal going forward at the project is that we're guided by that manifesto. We're continuing to sanitize and grow the current test suites we have. We're actively looking for participation, so don't make me continue to do this with only 5 people. Come help. If you have an expertise or an interest, or even advice, I'm really interested in having you come and participate, or at least talk to me after. We also are looking for useful tests, so if you have ideas about test suites that you like or that you've helped develop and you want to open source them or bring them to the project, please do. Obviously, what we've seen is the more you collaborate, the more innovation happens and the more fun you have. So I'm hoping that you'll join me at any one of these projects where I'm active or contact me in any way. I really do want the opportunity to know some of the stuff that you know. I know there are a lot of experts in the room on different topics. I want to be here to learn from you as much as I hope you can learn from me. So if you have questions, shoot them at me or come and talk to me after. Thank you very much.
Thank you. We have time only for one question.
Sorry, talked too long. Anyone with?
Questions?
Hi, Shelley.
Hi.
Thanks for the presentation. My name is Anton. I'm from Deutsche Bank Technology Center. So my question is a simple one. I thought that it will be the better question, I guess. So I see, and everyone saw that, how you download the tests. There were 3 builds, like OpenJDK and 2 more. But when the particular application is deployed, that's a good question. For example, I'm a developer. I want to download some tests and execute them. But how it works?
Yeah, so how it works is if you only particularly care about one piece, you saw that I was using something called a build list. The way we actually designed this is I can define a very small piece that I care about. If I say that I want from that external set of tests, if I only want the Scala tests, I can go and say the directory that I want. I define it in the build list, and we go and pick up just that piece. You download it, and we just generate the targets for that piece. So the reason we did that is because no developer has any patience to download everything. So we need to make things quick and simple. Then once we have defined the build list, all we're doing is running that configuration make, which then generates just the test targets from just that piece. Inside that folder, every folder that we add requires 2 files. It requires a build file to tell us how to build it, and it requires that playlist file to tell us how to run it, what things you want to run out of that file. So if you had defined the Scala folder, it would go and look at that build file, which in the build file, if there's any additional things that are needed, it goes and fetches them when you do make compile. And then in the playlist file, those are the targets that are generated, and you can go make Scala test, and it's going to run that functional suite.
So everything is just run on your machine, even a performance test?
Yeah.
Oh.
So it's not very valuable if you want to make sure you have, for performance benchmarks, a very set performance machine.
Sure.
But there are a lot of micro benchmarks that we also include. So for developers who want to run the micro benchmarks, they can just say, I care about the idle micro benchmark, and that's the one I want to run. Or the crypto benchmark, that's the one I want to run. And it gives them an early look at then what we might find in the nightly builds or in a later release build. So they can check things before they even merge code. Yeah.
Thank you so much.
Yeah, thank you. Yeah.